My presentation today deals with how to establish a maintenance program for high voltage apparatus like transformer, breakers, and more of this. And it's divided in two. I have a quick presentation of Zensol that you can see here. And after I will go to the how to establish a maintenance program for substations. So who is Zensol? It's a Canadian company founded in '90. We're a successful pioneer in the vibroacoustic diagnosis for tap changers and breakers. We are specialized in development, production, and well, I have a problem here. And sale of diagnosis instruments for high voltage apparatus. We are ISO 9001. So who are our clients? Maintenance teams of electrical utilities, mining, aluminum industrial companies, electrical maintenance service companies, breaker, transformer manufacturers, and the research laboratories and the universities. So this, you can see some references. Of course, one which is really important, it's Hydro-Québec, and all others throughout the world in all continents. So what we manufacture is instruments for OLTC diagnosis, like this one, TAP 4 Plus, who is able to do vibroacoustic and the dynamic resistance measurement at the same time. This one, the OATMX, is for the, it's a standalone tap changer analyzer. And of course, we are in Canada and we have no choice to perform in harsh environments. We have also instruments for breaker diagnosis. And our strength, of course, is with the vibro acoustic and also all classical tests. So we have customers in more than 50 countries. And this is the kind of transformers that have been tested with our instruments. This one here is like a 800 kilovolt technology of 70s, and this one is 750 kilovolt, but with only 1 or 2 contacts. So there is a big evolution in this area. So here it's what is the methodology for the maintenance programs of high voltage substations. So why maintenance? The best practice to avoid breakdown and not to compromise personal substation safety is to apply a proper maintenance. And this leads to the necessity of applying a multitude of maintenance actions, and of course, based on the inspections and tests. And in order to collect enough information on the actual condition of the breakers and the transformers. And with these information, after we can take a decision to proceed in time. So the next slide shows what kind of group of actions have to be taken. So here you can see the step one is to do an inventory. So of transformers, breakers, batteries. Here it's TC or CT, sorry. And here, for example, sectioners and so on. And with this information, you build what the step two is to do an observation and testing. So based on the information of the inventory, you can put all this information in a database. And after, you do like inspection and testing, and all this information comes from the monitoring. So it's like online monitoring. So as soon as you have like an alarm, so this information have to be reported in this database. The step three is to analyze and process all the data that you have collected in the first 2 steps. And then based on all these information, after you can plan interventions and for repair or refurbishment. So for the step one, what you need to do, the device chosen from the inventory can be a circuit breaker, a transformer a selector. For example, you can use some nomenclature like 1D for circuit breakers, 1M for measure transformer, 1U for power transformers, 1H, etc. Like this kind of required informations are general. The device, we call these device attributes, manufacturers, manufacturer date, first use date, warranty due date, like all this information, like utilization code. This apparatus, is it available? Is it under evaluation, in reserve, in repair, in service, engage? It's out of service. So all these details, but these general details are important to have. And here you have some specific characteristics like nominal voltage, current, the location, and the manufacturer also. So here you have some examples of breakers database where you can see here the type, the manufacturer, the technology used. It's important because with this information, after you could know what kind of actions you have to take on this these particular breakers, the year. On the step two, so this is what we call the observation and testing. So for the first group here, it's the information from the inventory. Here it's for example, the actions to be repeated on a periodic basis. And here, these informations come from, as I told you, online monitoring systems. So here, it's an example of inspection and periodicity table for breakers. You have routine inspections. You can see what is quick, like is, for example, a thermography, visual inspections, which is a good thing to do because it's easy and very quick. And the periodicity here is 1 year. After you establish a limited inspections. Here it's done every 4 years. Provisional inspection, so it's more and more deep. This is within 8 years. And for breakers, for example, you do a complete inspection after 1,000 operations. So it's exactly like a car. Like you have some systematic maintenance that you do in a periodicity, and or after a certain amount of kilometers. So it's exactly the same, between a car or a breakers. And here, this is an example of a required test for breakers and linked to international standards. And like the contact timing test, which is like an important test, motion and velocity, functional test, vibroacoustic test, first trip test, pressure, and a lot of others, of course, and all which is circled in red. Zensol instruments are able to do it. On the step 3, it's the analysis. So in fact, this database organizes for each piece of equipment the data collected, and it may include first test, inspections results over time, repair intervention, various information. And in fact, what we need, this information serves to conduct analysis to determine the type and urgency of maintenance interventions. And another benefit of this is that it serves also as a historical data for future statistical and durability studies. So for the analysis, what the wish is to have teams of highly trained engineers and technicians that can process all the information gathered in the previous sections and stored into well-organized database. And these teams have the responsibility to reach a verdict based on the analysis of the available information. And of course, after they can determine the required actions and priorities. And of course, so this information is put into a specific database used to prepare interventions. Here you have an example of collected database for breakers. Here you have it's a PE, it's a provisional inspections, like contact timing test has been done. The reports, the number of the reports is 433, the date and done by these people. On the step 4, it's the interventions. So it's with this, you can do a planning of interventions for repair or refurbishment. So this is the part that organizes and coordinates the inspection seconds. So the maintenance people can prepare the required maintenance actions in advance to increase global efficiency. For example, the purchasing department, warehouse, maintenance teams, operators. So it serves also as historical data for physical study and durability studies. So the specific database for maintenance interventions, this specific database has to contain the equipment serial number to identify the equipment being analyzed, the analysis report number with where we can find the recommendations, the advisory number, if any, priority level of each recommendation, the deadline for the intervention, the analysis date, analyst names. And here it's an example of advisories for breakers, and all the reported, the linked advisory. And here you have like the priority, like this one is urgent, and you have 1, 2, 3. And also the analysis dates and the deadline too. So what is an example, an advisory? Advisories are reports that inform the maintenance manager on what to do on each equipment. It contains at least a list of concerned equipments, a list of actions to do, list of parts, list of special tools, drawings, special instructions. And once the advisory is initiated, interventions can now be planned. For example, the result of a complete inspection of an interrupter module may reveal a critical condition that may require an intervention program on all similar breakers. So this requires coordination between network administration and maintenance teams. So a list to do actions, parts, and the special tools must be determined, not to mention training. On the part of training is really important. So you must put in place some job ad, videos or the checklists, so to help people to do the the exact actions and the good actions. Of course, the quality assurance is involved, the budget cost control. So once the intervention is completed, keeping a record of it is a crucial matter for comparison and future analysis. So, for example, a part's repetitive failure, for example, may raise concerns on more a critical problem or a design flaw. So this may influence the future of an equipment family. So for some specific breakers, you could decide to do a systematic replacement to avoid breakdowns or refurbishment. So here it's an example of completed interventions. So here you have the action plan, the team involved, the schedule, the start date, end date, when it's done. So here you have a to-do list. So this is the conclusion. The presentation has given the basic of setting up maintenance program, and this presentation is based on our personal experience with Hydro-Quebec's maintenance program. So Randy, I have finished. So
okay, great. Let's go to the questions. Yeah. Okay. What is the difference between SF6 inspection and G3 inspection? What standard do you use for other gases?
So, okay, look, in the SF6, it's the rule is to try to avoid to touch to this gas. So in fact, it's why like a Zensol, we have a lot of tests just to avoid to open the breaker. But I don't know if I answer correctly the question, because I can tell you honestly that we are not specialized in gas manipulation. Mm-hmm. We just take the breaker and the transformer as a piece of equipment, you see, and we do not touch it. We just analyze. It's if I can do comparison, if I take my heart, if I want to know my electrocardiogram, I just put a sensor, a transducer. That's it. But I'm not like a doctor in medicine to be able to open the body just to look at the heart. I don't know if it's clear.
What is the most common cause of circuit breaker failures?
Well, we have some statistics, and I recommend to go in our website. We have a section which is sharing knowledge, and here it's clearly we have like IEEE articles, and also from CGRE, close to 50% of the mechanical problems come from the leads to the failure of the breakers. It's more mechanical problems than electrical problems, and you have really the statistics in these articles. But I can share, if this person leaves his email, I can share it. He will have a good information.
Are these failures a maintenance issue? Are they caused by poor maintenance of breakers?
In general, yes, yes, because if you do like an adequate maintenance, you will avoid all these kind of problems. And like it's why for the vibroacoustic, we have specialized ourselves in the vibroacoustic, because it deals to the mechanical aspect of the operation of the breakers, you see, and just with some way to analyze your signal, you are able to detect problems early. And for some breakers, like it's very simple, because when you have like phase E, B, and C, which has a totally difference. So if you get like some typical noise from the phase A, B, and C, they must be the same. If they are not the same so quickly, you can say, hey, there is something wrong, and we have to find why.
Okay, good answer. All right. Yeah, what I've learned over the years is that maintenance is the #1 issue with breakers, right? Improper maintenance, neglect, and then they don't operate mechanically properly, and they cause failures like arc flash. Okay, great. Good presentation, Fouad. Thanks very much for the questions
you.
to you people.